Hey, so today, guys, we are going to be working on common factors and greatest common factors. This is lesson 1.5. It is on page 32 in your math book. I notice there are 3 vocabulary terms. I want you worried about these 2, common factors and greatest common factors. So up here in the highlighted yellow, we have the definitions up here. So factors are, common factors are numbers that are shared, are factors that are shared by 2 or more numbers. And the greatest of the common factors, so the biggest number, the biggest factor that those 2 numbers have in common is the greatest common factor. There are 2 pretty easy ways to figure out your greatest common factor, and we're going to go over both of them today. We're going to go over example 1 and example 2. We are not doing examples 3 and 4 because you just don't always need it, and so we're going for what can we get the biggest bang for our buck for, and that's it. In my math notebook, you'll notice that I have at the top of my page greatest common factor. That's the name of this. It's lesson 1.5 on page 32 and 33. If I were you, I would put the date on here. It's the 23rd, 10/23. But I'm not going to do that in case I need to use these next year if I'm teaching math again. I don't know. Anyway, I have my definition here for common factor and then the other one for greatest common factor. First thing I'm going to do is walk you through this example of using lists of factors. So I'm zooming in. Okay. First thing you're going to do is if you were to find the greatest common factor, it's always abbreviated GCF. So that's what you're going to see. You're going to see the GCF of 24 and 40. So first thing you do is you list all the factors of each number. So factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. And then the factors of 40 are 1 and 40, 2 and 20, 4 and 10, and 5 and 8. Then you go through and you're like, oh, what common factors? What do they have in common? They have 1 in common. They have the number 2. 2 is a factor for both of them. 4 is a factor for both of those, and 8 is a factor for both of those. So 1, 2, 4, and 8. The common factors of 24 and 40 are 1, 2, 4, and 8, but the greatest of these common factors is 8. So the GCF is 8. I have a couple of examples. If you could try to find the greatest common factor of 12 and 56 using these lists. First thing I'm going to do is I'm going to write down all of the factors of 12. 1, 2, 3, 4, 6, and 12. 1 and 12, 2 and 6, and 3 and 4. Then I'm going to write down all the factors of 56. Why do I keep doing that? I always write 52 instead of 56. I don't know why I do that. The weirdest thing. All right. 1 and 56, 2 and 28, 4 and 14, and 7 times 8. If you're good with multiplication facts, this will come easy. If you are not, then use a calculator. Use a calculator? Yes, please use a calculator. Miss Smith, how do I use a calculator to find the greatest common factor of things? I will show you. Okay, here I have this nice little calculator. There you go. You can see it a little bit better now. And if I wanted to find out the factors of 56, I obviously know that 1 and 56 work. But I know that 56 is an even number, so 2 will probably work. And I just type in 56 divided by 2 is 28. So 2 and 28 are factor pairs. And then I'll try 3. 56 divided by 3. That's not an even number. That is not a factor pair that I need to be writing down. So 3 doesn't work. What about 4? 4, oops, I did that backwards. 56 divided by 4 is 14. 56 does not end in a 5 or a 0, so I know it's not 5. What about 56 divided by 6? Nope. 56 divided by 7. Ah, yes. 7 times 8. Then the next thing would be 56 divided by 8, which kind of restarts my rainbow. So it would be going back here and finding all the buddies that go this way. So this is how, that's one way that you can use a calculator to figure out the greatest, figure out factor pairs to get your greatest common factor. After you make your list of all the factors, you're going to circle common factors. So 1, 2, and 4 are the numbers that are in common. So then I know that 4 is my greatest common factor. Go ahead and try on page 32 the on your own's numbers 1 through 3. So here's page 32. You're going to go down to the end of the page, and I want you to find the greatest common factor of 8 and 36, 18 and 17, and 14, 28, and 49 using lists of factors. So it tells you how to do that. Find the GCF using lists of factors. Pause your video and then come back when you have them all figured out, or at least you think you do. Okay, here we go. Sorry about that. You got to see my fancy camera work. I forgot to pause it. Are you ready? Okay. So first one, 8 and 36. I write down all my factor pairs of 8. It's 1, 2, 4, and 8. And then my list of factors for 36. This one has a lot. 1 and 36, 2 and 18, 3 and 12, 9 and 4, and 6 times 6, but you only list it once. Then I go through and I circle all the factors that they have in common. The greatest one is 4. Next, you'll have 18 and 72. Did you get that? These are big lists too. All right, here we go. There we go. Take a look. Did you find 18? When you have big lists like this, you can sometimes just take that second number. So take the bigger number, like 72, and divide it by the smaller of the numbers that you're trying to find a GCF for and see if it's the same. See if 72 is divisible by 18. That would save a lot of steps. It's another way to find your greatest common factor. So the GCF on that one is 18. And then the next one is tricky because you had to use 3 numbers, 14, 28, and 49. So once you figure out all of the factors of 14, you can look at those factors and see if they're factors of both 28 and 49. So I know that 1, 2, 7, and 14 are factors of 14. And then I can look to see if 7 is a factor of 28 and 49, or 14 is a factor of 28 and 49. There's my lists. Check yours on mine. And your GCF is 7. Hopefully you did a phenomenal job. We're going to look at factor trees next. Using our prime factorization, how do you find the greatest common factor? I'm not gonna lie, when I first figured this out, this was a struggle bus for me. So if I needed to find the greatest common factor of 12 and 56, using prime factorization, first thing that you do is you find the prime factorization of 12 and 56, which you should be well versed in. So you write it down, 12, the prime factorization of 12 is 2 times 2 times 3, and the prime factorization of 56 is 2 times 2 times 2 times 7. You circle the common prime factors. So you circle these twos that are in common and these twos that are in common. That 2 doesn't have a buddy up there, the 3 doesn't have a buddy down here, and the 7 doesn't have a buddy anywhere. So you just use these common factors and multiply those together. 2 times 2 is 4. So the greatest common factor of 12 and 56 is 4. I have another example just that I want to show you how I did this. So here's my extra example. I used 40 and 48. So I broke down both of them into their prime factorizations. So 40 breaks down into 4 times 10. 4 breaks down into 2 times 2, and 10 is 2 times 5. I write down the prime factorization of 40. And then 48 breaks down to 6 times 8. And then those all are composite numbers, so you got to break those down even further, and you end up with 48's prime factorization is 2 times 2 times 2 times 2 times 3. We have 3 2's in common, 1, 2, 3. So I take 2 times 2 times 2, and your greatest common factor is 8. Go ahead and try your on your own on page 32, numbers 4 through 6. 4, 5, and 6, go ahead and try those out. I'm going to pause this and then come back when you're done. Okay, welcome back. Here we go. Let's check them. All right, first we have 20 and 45. Here's my factor trees. Remember, yours can look different because there's lots of ways to get to the same answer when we do factor trees. There's lots of different ways that you can break it down, but your prime factorization is going to be the same. So 20's prime factorization is 2 times 2 times 5, and 45's prime factorization is 3 times 3 times 5. They have the 5's in common, but nothing else. So your greatest common factor is 5. If you don't have anything to multiply it by, it's 5. Numbers 5, 32 and 90. 32 and 90, they don't have anything in common but some 2's. Well, let's break it down and find out. So here's my factor tree. Remember, yours could look different, but it's going to be the same prime factorization. So I list my prime factorization. Why did I do that? Okay, caught myself there. All right, 32's prime factorization is 2 times 2 times 2 times 2 times 2, or 2 to the 5th power. 90's prime factorization is 2 times 3 times 3 times 5. They only have the 2's in common, so your greatest common factor is 2. And then number 6 is another tricky one because there are 3 numbers that you have to find your prime factorization for. Oops, let me move that a little bit so you can see better. Do your factor trees look like something like mine? Your prime factorization should be exactly like mine. The only thing that these ones have in common is 1, 3 and 1, 5. So 3 times 15, remember you multiply them together, is 15. The greatest common factor is 15. For your homework tonight, you're going to be working on lesson 1.5. Pages 35, I want you to do 7 through 12, and page 35, do 23 through 25. Make sure that you show your work like we did in this video, like they did in the book, on your own, the extra examples, everything. Do your steps like that, follow your steps like that. Save room for corrections in case you need them. And remember, odd numbers you can check in the back of the book to make sure that you're on the right track. Use the materials that you have. If you have any questions, please don't be afraid to ask. Send me an email, send me a comment on an assignment, and I'll get back with you.